Absolutely, and thanks for the intro, Gabriel. And it's a pleasure to talk to everyone for the 20th anniversary of OWASP. This is truly a historic moment. So Patrick and I are going to cover CycloneDX, which is a flagship OWASP standard targeting software bill of materials. So real quick before we get into the presentation, a little bit about myself, and then Patrick will introduce himself. As Gabriel mentioned, I'm the leader of the Dependency Track project. It analyzes SBOMs. I'm the co-lead and chair of the CycloneDX core working group, and I do a lot of other things in the software supply chain. When I'm not contributing to the open source world or the security space, I actually get paid to do software security architecture at ServiceNow, where I work with about 4,000 or so developers, trying to get them to build more secure and resilient software. So it's always a pleasure talking with and doing presentations with Patrick, because we literally live on opposite ends of the world. So I'm coming to you from Chicago, Illinois, in the United States, and Patrick is down under in the land of Oz. So Patrick.
Yeah, hi everyone. So my name is Patrick. I'm co-lead CycloneDX project with Steve. Participate in a lot of the same software transparency working groups and related efforts. Day job, software development lead for a government organisation down here, and open source software maintainer of a bunch of different things. I'll let Steve kick on.
Very good. Thanks, Patrick. So what we're going to be talking about today are SBOMs. And for just to give a high-level background of what we're trying to talk about is let's look at an analogy. An analogy would, in this case, is a list of ingredients on the back of an energy bar. So this is elementary, right? This is just a list of what that energy bar contains, which is interesting. But if I wanted to make risk-based decisions, this might be something that I care about. I might have allergies to different kinds of nuts, or I might have allergies to lactose. This helps me as an individual, as a potential purchaser of this energy bar, to make better risk-based decisions. And unfortunately, we don't have that same type of capability really widely spread in the software world, which is really what software bill of materials are for. And there's a lot of interesting contributing factors on why there's this increased awareness and increased rush to make software transparency much more in the mainstream. If you look at some of these statistics and these are all from Sonatype's 2021 State of the Software Supply Chain paper that recently came out, but there's some really interesting data points here. On the left here, we see that 73% year-over-year growth just in the consumption in using these open source components. That's pretty impressive of and by itself. But even more concerning is the year-over-year increase in the attack on the software supply chain itself, which we can go on a timeline and start naming these big company names. And I'm not going to shame anybody. It's just the reality of the software supply chain. It's complex. There's a lot of moving parts, and our adversaries know that, and they are actively targeting it. But there are some other contributing factors on why software transparency, and specifically why SBOMs as a vehicle for that transparency, are gaining momentum. Number one is just better software supply chain management. There's some very basic Deming principles at play here, which are using fewer and better suppliers, using the highest quality parts from those suppliers, and tracking our parts throughout their entire life cycle. There's market forces at play here, being able to measure the maturity of a development organization, whether it's your own organization, or maybe it's a vendor who might you be procuring software from. Or maybe instead of procuring software, maybe you're interested in buying a company itself. If we know what components are in our environment, we can also start reducing the operational cost of managing all these components. For example, if I have 16 different XML parsers and 30 different logging frameworks, well, that's probably unnecessary. And I can likely greatly reduce my cost if I whittle that down to 3 or 4 different libraries, right? Impact analysis, being able to know, for example, am I affected and where? Using an SPOM to determine what inventory is present in all these different assets in my environment. And then, of course, there's regulations. So most recently, the U.S. Executive Order 14028 that requires SBOMs for any purchase by the U.S. government. There's other regulations in place. The FDA has a bunch of pre-market requirements for software bill of materials, and there's critical infrastructure. For example, I literally just did a presentation for the energy industry earlier this week, and there's other critical infrastructure type things ongoing as well. So there's a really interesting list of critical or contributing factors here.
Yeah, and when we talk about software supply chain risk, it's sort of one of these unwritten rules that you've got to include this XKCD cartoon because it so accurately conveys, the way modern software is developed. It's built by a whole bunch of different components, and invariably when you start looking under the covers at your direct dependencies and then your transitive dependencies, you're going to find this little tiny component right down the bottom that's propping up your entire stack that represents a real risk to your organization. So with that, I'll let Steve introduce CycloneDX.
Very good. And I would really hate to be this lonely guy or person in Nebraska. That's got to be just a thankless job. But CycloneDX is, as we mentioned, is a flagship OWASP standard. It is a lightweight SBOM format. It's designed by security people and security vendors for cybersecurity use cases, and of course, backed by the most trusted security foundation in the world, which is OWASP. There's just a ton of credibility coming to the table here to make this SBOM standard a reality. It was designed originally in 2017. The very first release was in 2018, and we've had yearly releases ever since. We have a risk-based approach to standards development, which is very unlike every other standard that you probably are aware of. We're also very unusual for an OWASP project. Unlike most OWASP projects, we're kind of like this mini foundation without the legal entity of such. We have our own governance, very similar to Apache Foundation. We operate as a meritocracy. We have our own standards process. We also have our own working groups, industry working group, core working group, maintainers, etc. And we have a growing and wide vendor support and tooling support. It's a massive ecosystem that just keeps on getting better and larger over time.
Now, describing complete and accurate inventory is probably the foundational use case of all others with CycloneDX, and probably what you automatically think of when we start talking about software bill of materials. But CycloneDX in particular can describe pretty much anything you can think of: applications, frameworks, libraries, containers, operating systems, devices, firmwares, even files on disk. And with that complete and accurate inventory, you can start looking at things like security vulnerability analysis, which is obvious thing that pops to mind for people. And it's really enabled by good support of different component identifiers, CPE IDs, package URL, SWID tags, because there's different sources of vulnerability information. The NVD uses CPE, but misses out on a lot of open source software vulnerabilities, which is where package URL is really important. And of course, then you can start looking at integrity verification, because we've got support for many different hash algorithms. And this is integrity verification, different parts of your software lifecycle. So we're talking about hashes on packages that you're downloading and are coming into your build, or maybe it's the files on disk that are going into your build. And also then have the hashes for all the stuff coming out of your build. Does the package we've included, does it match what's available from upstream? Or, we had some sort of problem with dependency confusion or something like that. Is what we're making available to our users to download, is that what our build system said it created, or has it since been tampered with? Or even further down, when you're actually using something is what we're running in production. Does that match what the supplier said they gave us? And package evaluation. This is one of those use cases where I think SBOMs are really going to help uplift security across industry, because you start being able to proactively evaluate packages in much higher detail than you normally would. You know, if you're just looking at a direct dependency, it might look pretty good. First glance, you know, it might be maintained by a really respectable company and they might have a team that's looking after it. But when you actually start digging into the details, you might find that their dependencies are less maintained. You know, you might have something like the left pad incident where you've got a dozen lines of code which broke the build for a whole bunch of people in Babel and it was the React ecosystems. And license identification and compliance, you know, support SPDX license IDs and expressions, also support describing commercial licenses, evidence of licenses and copyrights. You know, particularly important, you know, there's some open source software licenses which can be very problematic, especially for commercial software, but can even have implications for how you use the software. And component assemblies is another use case that we support, particularly very complex component assemblies. Now, if going back to the analogy of the food label, you know, software isn't just a list of ingredients that's then thrown together. You know, there's a particular analogy that I know Steve likes, where it's more like a dash in a car. So within that dash, you've got instrument cluster. And within that instrument cluster, you're going to have a speedometer. And then within that speedometer, you're going to have LEDs, capacitors, things like that. You've actually got nested component assemblies, and those different components within that larger assembly will have different suppliers and different authors. And component pedigree is another important factor in this, especially open source software. You know, things are forked, renamed all the time. And so being able to describe the ancestry of components is really important. Look at all the different variations of, you know, Java, that different Java runtimes that are available. And there's some common ancestry there and some common problems then if there's a vulnerability identified in the ancestor, but also being able to then describe changes that have been made. Yeah, there's a leading identity management provider, and last time I checked earlier in the year, they were still shipping an outdated, unsupported, known vulnerable component of jQuery. But they took a risk-based approach to it. You know, just updating to the next major version could have broken authentication enterprise-wide for all of their customers. So that instead of that, they've got the jQuery component, they've forked it internally, and they just backport all the security fixes and fix any bugs that they come across. And that sort of thing can then be described. And that sort of richer information on component pedigree is going to be really important if there is going to be any transparency across the software supply chain. Provenance, so component provenance, the parties involved with that software, you know, the who built it, who packaged it, who supplied it, where did you download it from? And that sort of information is becoming increasingly more important when we sort of look at the global software supply chain and where issues happen. And services is another unique use case that CycloneDX supports. Perhaps not what you're thinking when you initially hear the term software bill of materials, but there's really, in a practical sense, there's not much of a difference between whether you're, you know, executing code that's in a DLL on disk, or you're calling out to an external service in the cloud, for example. So we support describing services, endpoints, whether it crosses the trust boundary, data classification, data flow, whether there's authentication requirements. Now, there's actually enough information in this to be able to generate a data flow diagram for threat modeling, for example. And with services and components, there's also dependency relationships. Now, you might have a transitive dependency that depends on an external service, or a transitive dependency that's got a known vulnerability, for example, and being able to figure out how that vulnerable component got into your software and which package you actually have to update in your direct dependencies, it's pretty important. But there's really so many different use cases we can cover, and lots and lots of different types of software and devices can be described. You know, classic legacy software, you might have a, you know, say you've got a fat client that runs on someone's workstation, it talks to an application server, which in turn talks to a database server. Now, that's something that you can describe in high detail with CycloneDX. Or perhaps it's a more modern web application. So you've got client-side code in one language, server-side code might be in another language, and then there might be a few external services that your system depends on. Mobile applications, you know, mobile apps, microservices. You know, you can describe with a CycloneDX SBOM, you can go right down to the microservice level, or you can take a step back and start describing a group of microservices that provide, that, you know, underpin your system, and the relationships between them and what their dependencies are amongst themselves, which microservices talk to another microservice, for example, and many ways that you can assemble system of system SBOMs. So you can have an all-in-one SBOM that contains absolutely everything, and in some modern application architectures, that can get really, really big and complicated. Or you can go right down to, yeah, things like the microservice level, and then build a consolidated SBOM that layers over the top that references those microservice SBOMs. It's really, really, really flexible. And I'll let Steve carry on to talk a bit about the object model that we use.
Thanks, Patrick. Yeah, use cases are really interesting. We'll touch on those in just a little bit more to give you some reference places that you can go to for some more information on all those. But let's talk about the object model, because the object model is really, really interesting. As Patrick was saying, we're talking about software bill of materials because that gets all the press, and that's specifically what was in the executive order. But CycloneDX is actually just a bill of materials standard. So we support a number of different types of components. And before I get to the components, I just want to focus on the fact that it's very lightweight. Many of us in the security world, we have to automate, not because it's a competitive advantage, not because it's the DevSecOps is the term of the last couple of years. A lot of us have to automate for survival purposes, right? We have to automate in order to do our jobs. CycloneDX takes that into reality into consideration with its approach to its object model. So it's very, very lightweight, and it's a very, very simple model that's optimized for highly automated environments. It's one thing to produce an SBOM as a point in time activity. It's another thing to be able to have an object model that can span across an entire build pipeline, so that as a bomb is going through your pipeline, you can augment it and change it and correct it throughout your pipeline. And the SBOM creation, instead of a one-time thing, is actually more of a process. And you need a really simple object model to be able to do that, because you need maybe a lot of simple tools to be able to operate on various aspects of the SBOM. And going back to the different types of components, as Pat was mentioning, we support applications and libraries and frameworks and all these other things that can represent in the software stack, as well as services. And yes, devices are also supported, although not overly well today. But we are working with the industrial control community as well as the IoT community to bring proper hardware support to the specification. So that's really the object model. Getting back to some of the use cases, the use cases really make CycloneDX as powerful as what it is today. Yes, we can talk about the object model and how good or whatever it is, but it's really about the use cases. Without the use cases, CycloneDX wouldn't be where it is today. So starting with the basics, like inventory is the most fundamental use case. But there's a lot of different types of use cases that you can explore. And we have a dedicated part of the website called the CycloneDX use cases and examples that actually gives you kind of an outline of what the use case is, as well as concrete examples, elementary examples for both XML and JSON to kind of walk you through this is how you would actually implement that use case for this particular serialization format. We also support protocol buffers as well for highly efficient machine-to-machine use cases as well. But there's a number of security use cases that CycloneDX supports, in addition to some of the non-security use cases, like license compliance being a non-security use case. There's all kinds of other non-security use cases that we support as well. But obviously, as an OWASP project, there's dozens of different security use cases that the specification is really, really good at representing.
And there's lots and lots of tooling available to help you get going. We've got a tool center on the CycloneDX website. It's got a heap of different tools, some open source, some proprietary, and for different sort of parts of the SBOM lifecycle. So there's some build integration tools. So this is, you know, tooling to embed in your CI/CD pipeline to generate an SBOM as close to the build as possible. You know, to get accurate inventory, you really need to sort of get that information when you're building it. But there is also some tools where you can build an SBOM after the fact as well. There's SBOM analysis tools, tools for authoring SBOMs. There's GitHub Actions as well to make generating SBOMs easy as part of your build. Tools to transform between formats. You know, as Steve mentioned, we've got different JSON, XML, and protocol buffer serialization formats. There's libraries available. So if you want to programmatically generate an SBOM or analyze an SBOM in the tool that you're maintaining, it's very easy to adopt. There's even things for signing SBOMs like Code Notary and Cosign, and for distributing SBOMs as well. And we've also got a few different ways that you can participate in the community. Obviously, the website's got a bunch of information on it. We've got the GitHub organization as well. It's got all our official implementations, things like that, all the repositories. We've got a dedicated Slack workspace there's a bunch of different channels in it. You know, there's channels for particular ecosystems. So things like there's a Go channel, there's a Java channel, .NET, JavaScript, etc. So it's a great place to ask any questions of not just the maintainers, but also the community at large. And we've also got a CycloneDX mailing list. So you can sign up there, and no, Slack isn't an option for some people who work in high assurance environments. So we've also got good old email as an option as well. Thank you, Steve.
Yeah, absolutely. It looks like we are ahead of schedule. So that never happens. But yeah, you know, like Patrick was mentioning, you know, we operate as a meritocracy. We do have different ways that the community can get involved, and I highly encourage if you're interested in software bill of materials and some of the work that not just the OWASP is doing, but many of the vendors that support the standard as well, what some of their work is doing, because some of it's really, really impressive. I highly encourage you to get involved. Like I was mentioning earlier, CycloneDX is kind of unlike every other OWASP project. It's quite large. I think we have almost, I don't know, 40 some odd repositories in our GitHub organization. And unlike most OWASP projects that have like one or two Slack channels, we have like 20, something like that. So it's a fairly large project. We have our own Slack workspace. So I will call that out as one of the differences. So we are not using the OWASP Slack workspace because, like I said, we've got like 20 some odd channels. But some of the work that we're currently ongoing right now, we are currently involved in development of 1.4 of the specification. So if you want to get involved and read what we're currently doing and read what's coming next, I highly encourage you to get involved with that. And like I was mentioning earlier, we do have our own standardization process. So if you want to get involved in that and making sure that we are providing a specification that does meet your organizational requirements, that would be great. So participate and help improve and move the specification forward. So Patrick, did you have anything to conclude with?
No, I don't think so. I think you covered it all. Yeah, thanks everyone for tuning in and listening to the talk. I always find it interesting talking to people about this stuff. So we'll be in the OWASP Slack channel afterwards. If anyone does want to have a discussion about SBOMs or any related topics.